Thanks everyone for watching my presentation. The title of my presentation is Three-Dimensional Transcranial Cavitation Localization by Four Sensors. Transcranial cavitation monitoring is critical to cavitation-mediated therapeutic techniques in the brain. Existing passive cavitation detection technique only require a single sensor, but it can tell where the cavitation occurs. 2D and 3D passive cavitation imaging can provide the spatial location information, but it requires phase arrays and time-consuming computation algorithms. The object of my work was to develop a 3D transcranial cavitation localization method using four sensors. Four flat sensor was used for passive cavitation localization. Here is the picture of the sensor positioned around a piece of ex vivo human skull. The proposed method is called differential cavitation localization, or DCL in short, which combine background subtraction with time difference of arrival algorithm. In background subtraction, we use the time domain signal of with microbubble minus the signal without microbubble to reduce the skull effects on signal to noise ratio. The time difference of arrival algorithm is commonly used in GPS system. It uses the time difference between the four sensors to estimate the spatial locations. This is a picture of the experimental setup. The focus ultrasound transducer was used to solidify the microbubble inside the tube. The four sensors below the skull receive cavitation signal transcranially, and the ultrasound imaging probe was inserted into the center opening of fast transducer for guiding the alignment of fast focus at the center of the tube. The fast focus location was used to indicate where the cavitation occurred. We carried out ex vivo experiment to evaluate the accuracy of the DCL method. The fast transducer and the tube was moved by a 3D positioner to different locations in 3D space. The location of the fast focus are represented by those blue dots. Then, we estimate the cavitation localization using our DCL method and quantify the offset between estimated location and the fast focus. Here are the results showing in XY plane and XZ plane. The blue dots represent the location of the fast focus, and the red dots represent the estimated location using our DCL method. Without skull, the mean value of the accuracy was 1.7 millimeter by averaging among all the points. With the skull, the mean value was 2.9 millimeter, which was comparable to that without skull. A 3D transcranial cavitation localization method was developed using four sensors combined with differential cavitation localization algorithm. Our future work is to further validate this method and assess its performance by in vivo experiments. I would like to thank the support from my lab and my advisor, Dr. Hong Chen. Thanks the funding support source. If you have any question, please feel free to ask.